is matter? Matter is anything that occupies space and has mass. You are very much familiar with this definition. And anything that occupies space and has mass is called matter. Okay. Now you are very much familiar with this definition. Now what we are going to study in this chapter, we are just going to study the physical appearance of the matter or the states of matters. When matter is going to change its state, it will be much better for me if you turn on your camera, so that there is an eye-to-eye contact between the teacher and the student, which can read the face of the students whether he or she is getting or not. So please turn on your camera. The video is safe. You are on the focus mode. Okay, don't worry about it. So let's start. Matter. So in this chapter, we're just going to study matter's physical properties. Okay, you know that on the basis of physical properties and the arrangements of atoms and the arrangements of atoms arrangements of atoms. Okay, we have divided the matter into three broad categories. We have divided the matters into three broad categories, and that we also called the states of matter. Okay, what are the on the basis? They are the solid, liquid, and gas. Okay, the matters has also been divided on the basis of their physical composition. On the basis of their physical composition, we have divided the matter into three broad categories. Like we have divided matters into, sorry, chemical composition, not the physical composition. We have divided on the basis of their chemical composition. Chemical composition, we have divided the matters into two main broad categories. One is pure and impure substance. Impure substance. The pure substance consists of elements and compounds. And impure substance consists of mixtures. This chemical composition we're going to study in the second chapter. So we're going to study in the second chapter. Okay. The physical properties or the matters, three states, that is solid, liquid, and gas, we're just going to study in this chapter. Okay. Got it? Got it?
Yes, sir.
You, Alfaiza?
Yes, sir.
Okay. Now,
Sir, my name is Alfiza Fatima.
What are you saying?
My name is Alfiza Fatima.
Alfiza, please turn on your camera. Why not? Like you study in the school, the teacher is in front of you. The same. If you went to some offline coaching, there teacher is in front of you. The same thing is happening here also. Okay, so that the teacher and the student. So is it okay when for the next time you have to open the camera, because I always allow the students to open their camera. Okay, because it is much better for me. It's okay for the first time. Are you having your copy notebook along with you right now?
Yes, sir. Yes, sir.
Now moving to the next part here is that we're just going to study one important concept of this chapter, that when we are just going to take their solid, liquid, and gas. We're not going to start with the first property that we're going to study characteristics of particles of matter, that particles of matter are continuously moving, particles of matter attract each other, particles of matter. We'll just going to discuss this in this chapter, but today we're going to study some important topic of this chapter, because we are just going to have 20 minutes and we're just going to study that portion first. Okay, so if I'm talking about the change in the states of matter, change in the states of matter, state of matter. Okay, so when the state changes, you know that solid changes into liquid. Okay, when solid changes into liquid, that is called melting. But you seen that one, that solid when changes into liquid, it is done at the same temperature. Like for example, if I'm taking ice, ice is 0 degrees Celsius. When you start melting ice, okay, it becomes liquid, and it will also, it was melting here. Ice start melting at 0 degrees Celsius, and here the liquid, okay, the liquid water is also at 0 degrees Celsius. Got it? Got it? The temperature is not,
Yes, sir.
okay, like you see here. Like for example, if you have a beaker, okay, like you have a beaker, and you place a flask over it, okay, and you place the flask over it, and you start heating this flask. You will notice that if you place a thermometer here, okay, you will notice that the temperature will not rise. Temperature, pressure will not rise. Will not rise. Okay, the temperature will not rise. Why? When still there are some ice cubes present here. Okay, there are some ice cubes. You start heating it. There are ice cube. You add it. You will notice that it is 0 degrees Celsius. You are just supplying the heat continuously. Let me show you in the video. That when you are continuously changing this heat, that okay, you are just continuously supplying the heat to it. Okay, you are just continuously supplying the heat, but you will notice that temperature is not rising. Temperature is not rising. Can you imagine why the temperature is not rising here? Can you imagine why the state is not, why you are continuously supplying the heat, but the temperature is not rising? The temperature is 0 degree unless and until all the ice get melted. Even if a small piece of ice is there in the beaker, all of the ice, other pieces are melted already. But unless and until all the ice get melted, uh, the temperature will not rise. And you are just supplying the heat. So where does the heat goes? Where is the heat?
Sir, the heat help in conversion of the steam, the water into steam, the latent heat.
Yeah, that we call it latent heat. Okay. So there is a specialized heat is being required when we have ice or solid. Solid changes into liquid, okay. When solid changes into liquid, the temperature remain constant. Temperature remain constant. Remain constant. Remain constant. Why do the temperature remain constant? Because there is specialized heat is being required. Actually, what is happening here? You know that solid particles are intact with each other. They are tightly packed. Okay.
Yes, sir.
And when they changes into liquid, the particles are free to move. The particles have some kinetic energy. Okay, here the particles have kinetic energy. Here the particle are intact. The particles are not moving. The particles are not moving means they are not having kinetic energy. And here the particles are having kinetic energy. So you know that energy can neither be created nor destroyed. If the particles are having kinetic energy here, and here they are not having the kinetic energy, so it means the energy is being supplied. Energy can neither, the heat energy is converted into kinetic energy, okay, of the solid particles, meaning increasing the kinetic energy of the particles so that it can convert into the liquid state. Because in the liquid state, particles are continuously moving. They move here and there. So for being to move here and there, they need to overcome the force of attraction. Solid particles are intact with each other. They are tightly packed. They are intact. Okay, you understood?
Okay, sir. Yes, sir.
Okay, so for, and they have very high force of attraction between them. So if you want to means it is only possible if they overcome. Okay, got
Okay,
it?
sir. Yes, sir.
So let's note it down that So this type of heat that is being required, you see that the temperature we are just applying. Okay, the heat we are applying, but it's still the temperature is not rising. So this type of heat is called latent heat. Latent heat. Latent heat. Okay. Latent heat means latent. The word latent come from hidden. Latent's word means latent means hidden. Hidden. Why we are saying hidden? Why we are saying hidden?
Um,
Why we are saying hidden?
so, because it directly help in making the water into steam.
Yeah. Because heat, we will simply say that it is called hidden. Why? Because we are just continuously supplying the heat, but the temperature is not rising. For example, you just take a glass of water. Okay. And just heat, just it is just a water of 20 degrees Celsius. Okay, like it is 20 degrees Celsius. You just place it on the burner. Instantly after 7 to 8 seconds, 8 seconds, you will notice that the temperature start rising. You will notice that the temperature is not 20 degrees. Means instant on supplying the heat, the temperature start rising. But here you will notice that they are the ice cubes here. And you are just supplying the heat. Okay, you are just continuously supplying the heat, but the temperature is not rising. So here temperature is not rising. Temperature is not rising, not rising. And here the temperature rises instantly. Temperature rises, rises instantly. Why? Because here the state is being changed. State changing process taking place. Here, state changing process taking place. The state changing process is taking place. Is taking place. And here, no state is being changed. At 20 degrees Celsius, water does not change the state. It remains as liquid. So no state change. No state change take place. So the question comes in examination that what is latent heat? So latent is the amount of heat that is being required to change the state of matter. Okay. So note it down. What is latent heat? It
But
is the amount.
sir, there are two kinds of latent heat, right?
Yeah, we are just going to discuss that one also. It is the amount of heat. It is the amount of heat required to change the state of matter. Okay. Without rising the temperature. Without rising the temperature. Okay. Without rising the temperature. Latent heat is the amount of heat required to change the state of matter without rising the temperature. Okay. Note it down. Okay. Now the latent heat is without rising the temperature is important. That's why it is also called latent. Latent means hidden. Hidden because when this heat is being absorbed, the temperature do not rise. That's why it is called hidden. Other heat instantly increase the temperature, but in case of latent heat, the temperature do not rises unless and until the wholly state is being changed. It is the amount of heat that is being required to change the state of matter. Now latent heat is of two types. It is of two types. Latent heat of latent heat of vaporization, vaporization, and latent heat of fusion. First, we will write latent heat of fusion. Fusion. Second one is latent heat of vaporization. You understood this one? Now, Faiza, tell me that what is latent heat of fusion? What is the definition for the latent heat of fusion? Faiza, you there? Alfaiza, are you
Sir,
there?
Yes,
Kachal.
sir.
Tell me what is latent heat of fusion?
Sir, latent heat of fusion, the temperature that helps in the changing of solid into liquid.
Temperature or heat?
Sorry, heat.
Okay. Now it is a specific, we will simply say that it is the amount of heat that is being required to convert 1 kilograms of
Okay, sir.
solids into liquid without rising the temperature. There is condition, there should be 1 kilogram of solid substance. Okay, so note it down, definition of for latent heat of latent latent heat of latent heat of fusion. Note it down. It is the amount of heat. It is the amount of heat required to convert 1 kg of solid into liquids at its melting point without rising the temperature. At its melting point without rising the temperature. Without rising the temperature. Please note it down. When you done, please let me know.
Sir, done.
Done? Okay. So just a minute. Okay. Now, if I'm talking about further, you know that latent heat is the amount of heat being required to convert. Similarly, the latent heat of fusion, latent heat of vaporization. Vaporization. Simply say that it is the amount of heat. It is the amount of heat required to convert 1 kilograms of liquid into gas without rising the temperature and at its boiling point. Boiling point. Okay, please note this definition also. At its boiling point.
Sir, done.
Are you taking the screenshot?
No, sir.
Sayyeda, you done?
Yes, sir.
Very good. Proud of you. Okay, let's move further. Next, if I'm talking about this one, now, when the state question comes that where does the heat goes when liquid changes into gas, sorry, liquid ice, solid, we, when we are just melting the ice, we are just completely continuously applying the heat, but the heat is not, you see that the temperature is not rising. So the question comes that where does the heat goes when during the melting of ice, during the melting of ice is still heat is continuously supplied. So please note it down. Where does the heat goes? Answer will be the heat goes in overcoming, in overcoming, the heat goes in overcoming the force of attraction, coming the force of attraction. The heat goes in overcoming the force of attraction between of solid so that it will change into liquid. Note it down. Where does the heat goes in over where does the heat goes during the melting of ice? Still heat is continuously supplied. So heat goes in overcoming the force of attraction between the particles of solid, means ice, so that it will change into liquid water. Okay, in the form of latent heat of fusion. Latent heat of fusion. Okay, note it down. Hello, Ayan. How are you? Is I'm audible to you?
Yes, sir.
Okay, wait for some minutes so that this will may also go on. Okay, just wait.
Okay.
So done.
Done. Next, one thing you also say that you noted.
Yes, sir.
The next question comes here. One thing that, for example, if I'm having this state, you are changing the states. Like it is 50 degree, okay, 50 degree Celsius water, okay, and then it is 0 degree Celsius water, and this is minus 10 degrees Celsius, minus 10 degrees Celsius, okay, minus 10 degrees Celsius. So if you are just cooling the water, okay, you will notice that when at 0 degree Celsius, it is for water. Graph for change in state of water from 50 degrees Celsius to minus 10 degrees Celsius. So you know that at 0 degree Celsius, it will remain, it will for some time, okay, we'll say that 0 degree temperature is here, okay, and you know that ice, liquid water melt at 0 degree Celsius and freeze at 0 degree Celsius, okay. So when the 0 degree Celsius is achieved, then for some time the temperature remain constant at 0 degree. For some time the temperature remain constant as 0 degree. Why? Because why? Because simply we'll say that because here the change in state is taking place. Change in state is taking place. Okay, since the change in state is taking place, and after that it will start further dropping. So it will remain constant. Similarly for the boiling also. Similarly for the boiling also. If you are boiling water, okay, so let it is 0 degree Celsius. Okay, 0 degree water. Okay, or yeah, 10 degree water. We are saying this is 10 degree water, 10 degrees Celsius. It is 50 degrees Celsius. Then it is 100 degrees Celsius. Okay, so we'll notice that water will the temperature will keep on rising when you start heating, but at 100 degrees Celsius, temperature will remain constant. It will not rise unless and until whole water get evaporated. Whole water get converted into vapor. Okay, it is not possible that you are having a water at 110 degrees Celsius and it is in the liquid state. No, The water boiling point is 100 degree. So when 100 degree temperature is achieved, it will convert into vapor, and till unless and until whole water get converted into vapor, the temperature will remain as 100 degree. Okay, so this will, for some time, the temperature will remain 100. It is, we'll say that this is a change. Here the change in state is taking place. You understood, I am? Understood? Yes or no? Ayan, are you there?
Yes, sir.
Okay, just a minute. Let's have some question over it. Then you done? Noted this one, father? And Sayyada,
Yes, sir.
Madiha, you done?
Yes, sir.
Okay. So please note this question in your copy, and then let you please tell me the answer for this question. Note this question in your copy, please. Note this question in your copy, and then let you know the answer. Let you tell me the answer for this question. Ayan, can you tell me
Yes,
the last
sir.
topic that we studied in the previous class?
In our last class,
What are you saying?
like in our last class,
Yeah.
we were like studying about I forgot its name. Uh,
Okay.
like we put like some chemical in like some glasses with water
Check
in
check
it.
in your copy. The last topic that we did. Check in your copy. Check in your copy.
Yeah, it was illustration activity to show that particle of matter are very very small.
Okay. Please note this question. You noted? You noted this one?
Yes, sir.
Okay. So tell me the answer for this question, please. What's the answer for this question? Tell me the answer. You see that here a glass tumbler containing hot water is kept in the refrigerator compartment, and the refrigerator, okay, which is having a temperature minus 0 degrees, means below 0 degree, temperature less than 0 degree. Okay, if you could measure the temperature of the content in the tumbler, means you are just changing the temperature. So which is the correct graph? Which graph do you think is correct? So here
Sir, A.
first, yeah, it
The
would be
first one.
the first one, A. Okay, why? Because here you will see that it will keep on decreasing, but when 0 degrees temperature is achieved, so it will remain as it is 0 degree unless and until whole water get. It is not a second of time fraction. If you take a glass of water, you start freezing. So temperature will be achieved at 0 degree, but it will take time unless and until whole water get converted into 0 degree Celsius ice. So the temperature will remain constant. So here this temperature will remain constant. Okay. So for 0 degree Celsius. So it is the A is the correct option. You understood now? And then further
Yes.
it will keep on decreasing constantly. Next question. Note this question also in your copy. Note this question. You noted this one, please? Tell me, you noted?
Yes, sir. The answer is the last option.
Answer is the last. Okay, let me check it. Here, you will notice students heat the beaker of ice because you know that the temperature of ice is 0 degree Celsius. 0 degree Celsius. And start heating the water. He measure the temperature of the content of the beaker as a function of time. Means the temperature is increasing with the function of time. Okay. Got it? Which the following correctly represent the choice. Okay. Which of the following correctly represent the choice? So this is very simple that here the temperature is continuously rising. Okay. But you see that for the first time, the temperature will remain as it is zero, as zero. Okay. And then after the temperature will keep on rising. Got it?
Yes, sir.
Yes. Okay. Here the temperature, it is not incorrect because you are not just boiling the water, you are just changing. This is for the boiling of water. This is for boiling of water from 0 degree water. Okay. From 0 degree water to 100 degree water, degree Celsius water. This graph is for this one. Okay. This graph is for cooling vapor. Okay. And this graph is for condensation of water. And you are just condensing the water from 100 degrees Celsius and you are. So this is the for condensation of steam or condensation of. Simply we say that it is cooling of water from 100. It is coming here. Okay. Got it? Is it changing into ice here or not? In the C option, is it changing into ice here? The C option? Yes or no? Tell me fast. Is I'm audible? Hello?
Yes, sir.
Yes,
Why not responding? Everybody is keeping silent. Please turn on your camera. Everyone, please turn on your camera. It is compulsory for everyone to turn on your camera. Ayan, you turn on your camera, please. Are you not getting my voice? Okay. Alfaiza,
Yes, sir.
please turn on your camera. Okay, now the questions, the type of question that is going to come here, let me explain you. Okay, let me explain you. The type of question that we're going to get, this is very important topic, latent heat, okay? This is going to study. You know that water, okay, if you have ice cubes, if the question comes that which is more effective in cooling, which is more effective in cooling, okay, which is more effective in cooling, like 0 degrees Celsius ice ice or 0 degree Celsius water. Can you explain me, anybody in the class, that if you have, like, you have a student A has ice cubes in his lassi and is okay, okay, this is an ice cubes. Student A added ice cubes in the lassi. This is A student, and a student B added same amount of lassis here, okay, and he added liquid water, 0 degrees Celsius water to it. This is student B. Student B. Can you tell me that student A lassi will become more colder or student B lassi will become colder?
Sir, student A lassi become more colder.
Why?
Um,
Just tell me the reason. Yes, Madiha, you tell me. Do you think that student A add some ice cubes to it? Student B add 0 degrees Celsius water to it, to his lassi. Both are means both ice is also at 0 degrees Celsius and water is also 0 degrees Celsius. Okay, you know that at 0 degrees Celsius water can be in two states, solid and liquid.
Yes.
So this is chilled
Yes.
water, 0 degrees Celsius water. Which do you think is more effective in cooling?
Um, the 0 degree ice cubes, because they I don't think I know the reason, but maybe it's your ice cubes.
Yes, you Ayan. Which do you think is more effective in cooling?
the water.
Water is more effective in cooling. So let me explain you here one thing. Okay. So here you know that when we are having 0 degrees Celsius ice, okay, and here it is changing its states from to 0 degree water, changing its state to 0 degree water. Okay. So from 0 degree ice to 0 degree water, it is changing its states. Okay. So ice will start absorbing heat. Okay, like you have a bottle. Okay. You just take chilled bottle. You are just moving, you are just traveling from position A to position B. Position A to position B. Okay. A person and you are having two bottles. One bottle is having ice. Is you just kept it in the refrigerator. Okay. Okay. And it is filled with ice. Means you just keep it in the deep freezer or the upper portion where it is freezer and it get condensed. Okay, there is ice in this bottle, and bottle B or another bottle is just about to chill, just about to freeze, but it is not ice. It is liquid water. It is liquid water, 0 degree, chilled water. Nice. Okay. So we'll say, you will notice that, sorry, this is 0 degree water. This is 0 degree water. 0 degree Celsius water. And this is 0 degree Celsius ice. Okay. Now you will notice that the water at 0 degree Celsius, when you move it or take it to some place in the hotter day, it will start getting instantly warmer. It will start getting instantly warmer. After some time, you will notice from 0 degree, like 1 or 2 minutes later, you will notice that this changes from 0 degree to 1 degree, then 1 degree to 2 degree, then 2 degree to 3 degree, then 4 degree. They keep on increasing. Okay, but you will notice that the ice, unless and until whole the ice will take time. So unless and until whole ice get melted, the temperature of the bottle will remain 0 degree. It will not instantly increase. Why? Because when the ice is converting into water, it is absorbing the heat, but still it will remain at 0 degree. It will remain at 0 degree unless and until whole ice get melted. Then whole ice get melted, then it will remain equivalent to this bottle. Then after it will keep on increasing its temperature. So if I'm coming back to my question here, that which is more effective in cooling. So you know that ice is more effective in cooling because ice will absorb extra heat. Ice will start absorbing the heat in the form of latent heat. Okay, it will change into water, and and this will be 0 degree water. It will absorb the heat in the form of latent heat. Latent heat. Okay, you understood?
Yes.
Understood? So we'll
Yes, sir.
simply say that why? Because why ice is more effective? Because here the change in state is taking place. Here the change in state is taking place. Change in state is taking place. So we'll simply say that ice is more effective in cooling. Simply say that ice is more effective in cooling than liquid water at 0 degree Celsius because ice absorb extra heat in the form of latent heat. And now you know that if the ice is absorbing the heat from latent heat, from where it will absorb? It will absorb this heat from the surrounding. And what is the surrounding? Surrounding can be your juice, surrounding can be your lassi, surrounding can be your anything in which your cold drink, anything in which ice cubes are added. Okay, so surrounding is that thing. Okay, so if it start absorbing the heat from the juice, it will start absorbing the heat from the cold drink. Then in turns, the cold drink will become colder because its heat has been stolen by the ice. So in that case, the juice will become colder. So we'll say that, or the lassi will become colder. The ice is more effective in cooling than liquid water at 0 degree Celsius because ice absorb extra heat in the form of latent heat. Okay, but the liquid water will not. Whereas the liquid water will not absorb. Understood? You know that because when water is at 0 degree Celsius, it is water. It will not absorb. Okay, it will not absorb the latent heat because it is already at liquid state. It is latent heat is only absorbed when the state of matter is being changed, when it is changing either from solid to liquid or from liquid to gas. But when 0 degree water is already water and it is keep on increasing the temperature, there is no state of change of state is being changed. It is still 0 degree. At 2 degree, 3 degree, 4 degree, it will remain at 0 degree. It will remain in liquid state unless and until the temperature reaches to 100 degrees Celsius. And no juice is at 100 degrees Celsius. So we'll simply say that ice is more effective in cooling than liquid water at 0 degrees Celsius because ice will absorb extra heat in the form of latent heat, whereas the liquid water will not absorb this extra heat. This extra heat. Okay, you understood?
Yes.
Yes, sir.
Madhya, you
sir.
understood? Okay. So what is the difference, if I ask you, what is the difference between the 0 degree Celsius ice and 0 degree Celsius water? It has latent heat of fusion. Latent heat of fusion. And it do not have latent heat of fusion. So it will keep on increasing. When ice is being changed into liquid water, it will keep on absorbing the heat in the form of latent heat of fusion. Okay, you understood? Should I move forward?
Yes. Yes.
Yes, sir.
Okay. Here, if I'm talking about the like the steam, the question comes that if a person, okay, which cause more severe burn? Question comes in examination. Let me have this question here. These are the questions in your examination that is going to come in your examination. Here are the questions that is being asked. Water as ice has cooling effect, whereas water as steam may cause more severe burn. Means water as ice has extra cooling effect when we have adding ice to, and similarly when water is in the steam form, it cause more severe burn. Similarly, this is question number 2. Alka was making a tea in the kettle. Suddenly, she felt intense heat from the puff of steam gushing out of the spout of the kettle. She wondered whether the temperature of the steam is higher than the temperature of the boiling water in the kettle. Comment means simple. She is saying that she comes in the steam when she is making the tea. Then suddenly the steams coming out from the kettles get uh, touched with her hand, and here will simply say that when she's interact with that with the steam, so she feel that the temperature of the steam is much higher than the boiling water. So why does she feel? So similar question may comes in examination that why do why do the burn caused by steam, burn cause caused by steam, why do the burn caused by steam, burn caused by steam is more severe than the burn caused by boiling water. Than the burn caused by boiling water.
So this happened because of the latent heat of vaporization. The steam contained more temperature. That's why steam is more
Temperature
severe
is
than.
same. Temperature is same. Both are 100 degrees Celsius. Steam is also 100 degree.
Sir, I mean the
Heat.
heat.
The temperature and the heat are the
Yes,
two
sir.
different things.
Yes, sir.
Okay. Very good. Very good. So when let's suppose this is simple, very simple, that when the steam is coming into contact with your hand, then it will release an extra heat on the hand. Because what is the difference between the 100 degrees Celsius water, boiling water, and 100 degrees Celsius steam? So it has an extra heat that is called latent heat of vaporization. Latent heat of vaporization. Otherwise, they both have same 100 degrees Celsius, but steam has an extra heat. When 100 degrees Celsius water changes into 100-degree steam, it will absorb an extra heat in the form of latent heat of evaporation. Latent heat of evaporation. So simply we will simply say that here this is 100 degrees, this is steam is 100 degrees, both are 100 degrees. But what is the main difference? That steam has an extra heat that is called latent heat of evaporation. It will absorb extra heat and get converted into 100 degrees Celsius. So water when absorb extra heat, so it converted into steam, that is called latent heat of evaporation. Steam has extra heat that is called latent heat of evaporation. This water do not have. So when the steams come in our contact with our hand, then it will release extra heat that is called latent heat of evaporation. That is called latent heat of evaporation, while the water will not release that extra heat, because water do not 100-degree water do not have this heat. Only the vapor has, only the gas has this latent heat of evaporation. You understood? Understood?
Yes, sir. Yes, sir.
So the answer for this question will be that why do steam cause more severe burn than the boiling water at 100 degrees Celsius? Because we'll simply say that steam has extra heat in the form of latent heat of vaporization. Okay, latent heat has extra heat in the form of latent heat of vaporization. Steam, whereas liquid water do not. Liquid water at 100 degrees Celsius do not. So steam will release extra heat and cause severe burn. You understood, Madhya?
Yes, sir.
So note it down. Steam has extra heat. Ayan, are you writing this one?
Yes, sir.
Show me a copy, please. From the back camera.
I don't know
Show me
how
a,
to.
yeah. Show me whether you are writing the questions or not. Yes. Just a minute. Let me check. Yes. Okay. Show it again. By the back camera.
I didn't write the full question yet. Where I'm writing.
Go back. Go. Show me the previous page. When you have not written anything. You have not written anything.
No, I was writing, but I took some screenshot because I was not able to
Who
write.
told you to take the screenshot? Who told you? Did I say to take the screenshot? Did I said?
No.
Did I said, Ayan?
Yes, sir.
You are having 1 hour. I'm just writing for you. I'm also taking the time not to write it. So when I'm writing you, why can't you write? Why you need an extra time? You will not do that when I know. After the class end, you are not going to do. You will throw this copy somewhere else. And this is going to be very important. Yes, you. Faiza, your correct pronunciation is Faiza or Fiza?
Sir, Alfiza.
Alfiza. Okay. Alfiza,
Yes.
tell me, show me your copy with the back camera, please.
Yes, sir.
whether you are writing or not. Okay. Okay, yes, you. Uh, uh, Madiha, show me your copy, please,
Yes, sir.
by the back camera.
1 minute, sir. Let me just. Yeah. And there's notes over here also.
Okay. So, man, should the team, should I contact the team to call your parents that you are not writing it properly? Should I? In the previous class, you were doing class like you were just, I asked you to turn on your camera, you were just lying on the bed and you were just taking the screenshot. I remember each and everything. You were doing like that now. Why you are so lazy about this? Why? I have this all each and everything already written. Let me show you. Let me show you that I'm not lazy, even though I have written this one in the previous classes for the students. Okay, I can open that notes and I can say that copy it from here because I have already written. Okay, let me show you that. Let me show you. This is the slides that we use for the students. Okay, just a minute. I have already written each and everything. Okay, what I need to say is that dear student, please, this is the question. Okay, this we have done. Okay, this is the graph that we have done. Why do ice float on the surface? Why is ice effective in more cooling that water? Okay, this we have done already. Latent heat of vaporization we have written. Okay, this latent heat. What I need to say is that I can explain you like this way. Why do, yes, I can explain you like this way. Here, wrote it down. Just keep on. I just keep calm down. Why there is a need? Why I'm just writing it again? Because when I write it, you will just look at the screen. You will hand to hand. You are going to write that one. But the teacher is doing the effort which is already written. I'm just writing. I'm just saying it you to write it in a copy, and you are not writing. So I'm just leaving you for the first and last time. I am. The next class, I will not allow you. Okay, beta. This is very important for you that you need to write each and everything properly. The notes are not maintained, then your memory is going to lose each and everything. How will you memorize that what side has answered? The screenshot will not going to work. I know that you are not going to write it after the class. Today you can write because I'm just scolding you right now. But the next class, you are not going to write. So in my class, every notes, the copy should be separate. If you are studying chemistry copy should be separate. There should not be physics, maths, and bio there. Only chemistry copy should be there. It should be properly maintained. Coaching institutes copy should be properly maintained. I'm not talking about your school notes. School copy should be different. Coaching copy should be different. There should be 3 copies for the science, physics, chemistry, and bio, and 1 copy for the maths. Okay, that is very important for you. The next class, you are not going to do that one. Okay, you promise me. Promise me that, sir, I will not do this again.
I will not do this.
Okay. So if I'm writing each and everything for you, then why are you doing such thing? I can explain you here also. Okay. So now you understood, all of you. Now you understood each
Yes,
and
sir.
everything. That why do steam cause more severe burn? Why ice at 0 degrees Celsius is more effective in cooling? And secondly, what is latent heat? What is latent heat of vaporization? What is latent of fusions? Why the temperature remain constant when the state is being changed? Okay, when 100-degree water is converted into 100-degree vapor, or 0 degree, what this 0 degree ice is converted into? Why the temperature remain constant? Where does the heat goes? Okay, so this type of questions that you are going to study thoroughly each and everything. Okay, this is very important topic, and it is called latent heat of uh latent heat. This is an important topic. Change in states of matter. Okay, got it. So let's have some questions over this topic. Some more questions. Okay, one more thing, that when we are having when we are changing the states of matter, okay, so there must be something like, for example, solid changes into liquids. Solids are changing into liquids. So you know that at this step, at this time, the temperature remain constant. Okay, let's first write that solid changes into liquid, that is called melting. Melting. When liquid changes into gas, liquid changes into gas, that is called vaporization. Evaporation or boiling, that is called evaporation, ration, or boiling, or boiling. Okay, and when gas changes into liquid back, that's called condensation. Condensation. And when liquid changes into solid again back, okay, back, then it is called freezing. That is called freezing. But sometimes solid changes directly into gas without going into the liquid state. Like you see here, that solid changes into gas directly without going into the liquid state. Okay, and that is called, that we called it that is called sublimation. Okay, sublimation. Sublimation. So what is sublimation? When solid changes directly into gas without going into the liquid state, that is called sublimations. Okay, got it? And when
Yes.
gas changes directly into solid without going into the liquid state, that is called deposition. That is called deposition. Okay, so let you note it down from here so that you can understand it more betterly. Just a minute. Make this one, please, and note down the definition of sublimation, please. The process of convergence of solid directly into gas without going into the liquid state is called, note this one, please. And then note down deposition. When you're done, please let me know.
Done.
You done?
Sir, done.
Yes, sir.
Okay. But sometimes, note down the examples of sublime substance that changes directly into gas without going into the liquid state. Note the example, that is camphor, naphthalene balls, deposition. Okay. Have you noted the definition of sublimation also?
Yes.
Yes, you, Matia, and Alfaz,
Yes,
and
sir.
Yes, sir.
I am. Okay, sir, I am Alfiza, sorry. The name is new, so that's why it will take some time to be on my tongue.
It's okay. It's
So sometime if when the gases changes into solid without going into the liquid state, that is called deposition. But if in the option deposition word is not being given to you, then we will give sublimations. Okay, means solid changes into liquid, it is 100%. Sorry, solid changes into gas without going into the liquid state, that is called sublimation. That is called sublimation. But if if the if the gas changes into solid, that is called deposition. But if the deposition option is not given, then again we'll give the preference to the sublimations. Okay, got it?
Yes.
For example, let have a questions here. Just a minute. Let have a question here. Give me a- Okay. Let's have a questions. Okay. Just tell me the answer for this question, please.
So second option B.
Yeah. Second option B, you are saying. Another? Yes, you. Madhya, what's the answer? And Ayan, yours? What should be the correct answer here?
One minute, sir.
Same answer. B.
Yeah.
Yeah. So here you will say that convergence of solid into vapor. Solid into vapor without going into the liquid state is called vaporization. No, it is sublimation. That's why this option is incorrect. Conversion of vapor into solid without going into the liquid state is called freezing. No, it is called deposition. If the deposition option is not given, we'll go to the sublimation. That is also incorrect. Conversion of solid into liquid is called sublimation. Solid into liquid is not sublimation. It is melting. So that this is
It's known as fusion, right, sir? Because in school we were told that
so
it's
yeah,
fusion.
it is fusion or melting. You can say that this is also called fusion or melting. You both you can use. Okay, melting. When ice changes into liquid, it is called melting. Okay, got it? Or you can also say that fusion.
Yes, sir.
Next, next we're going to have the if this question comes in an examination, will you be able to answer this question? Will you be able to answer this question? Why does the temperature of the substance remain constant during melting and boiling points? Yes, Madhya. Will you be able to answer this question? And Alfiza and you, Ayan? While the temperature remain constant during melting and boiling points. Because at melting and boiling point, that state is being changed, and the heat that we are supplying is being utilized in converging the state of matter. Okay, in the form of latent heat. Got it? So note it down. Note the answer for this question, please. That why does the temperature remain constant? Temperature remain constant during its melting and boiling point. Ayan, are you having copy along with you right now? Show me your copy. Are you writing now?
Yes, sir.
Okay. Why do temperature remain constant during melting and boiling points? So we'll say that at melting and boiling temperature, at melting and boiling points, solid changes into liquid, solid changes into liquid, and and liquid changes into gas respectively. Therefore, s- therefore, for the heat we are supplying force in overcoming the force of attraction in the form of latent heat of fusion and vaporization respectively. That's why the temperature do not rises. That's why the temperature do not rises. Okay, note it down.
Sir, done.
You done?
Yes.
Yes, sir.
Okay. Okay, done. So let's move further. So this question comes in your examination. Will you be able to answer?
Yes, sir. I know the answer.
Okay.
Should I say?
Yeah.
The amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion.
Very good. Now, one thing we know that when we are just studying this state of change of matter, and it occurs at particular temperature that is called boiling temperature. Okay, boiling point or melting point. So if I'm talking about the boiling point, boiling point. So what is boiling point? The temperature at which the vapor pressure of liquid become equal to atmospheric pressure. Become equal to vapor pressure of liquid become equal to atmospheric pressure. Actually, if I show you one thing here that, for example, you have a boiling point. Okay, we have said that boiling point of water is 100 degrees. So actually, water particles are intact with each other and they are free to move. But there is an atmospheric pressure over it. The water particle on the surface, and they are free to move. They can freely move. But there is an atmospheric pressure over the surface, that is an air. Water can boil. We'll explain you in the next class that water can boil at temperature lower than 100 degrees Celsius. Water can boil at 100 degrees Celsius, at 85 degrees Celsius. Water can boil at 23 degrees Celsius. It can boil. If you remove this atmospheric pressure over the surface and create a vacuum, so we'll say that when the These particles are exerting a pressure over it. They want to go, but the atmosphere is applying the pressure over it. They are not let it to go. So we need to heat this substance so that kinetic energy of the particle is enough that uh it can force it up. It can force it up and let it go. Okay, the particles can move freely. Understood? So what is boiling point? The boiling point is that points. Let me show you the video here. The boiling temperature is that temperature at which the vapor pressure of the liquid becomes equal to the vapor pressure of the liquid.
Atmospheric pressure.
Yeah, sorry, atmospheric pressure. So let me show you. You here, so you can understand. Just a minute. So you can watch here that